Right, grade 11s, we've so far have done 3 different types of reduction. Now we still have 2 things to go in order to complete our skill set for this type of question. And so this topic is about negative angles and angles bigger than 360 degrees. So let's first start looking at negative angles. The most important thing to realize about a negative angle is a negative angle simply means that you've gone clockwise from the x-axis. A positive angle means anti-clockwise because that's the way it was originally defined, and so a negative angle simply means you've gone clockwise. So if, for example, you're drawing an angle of negative 30, I would have just gone clockwise by 30 degrees. So that would be called negative 30 degrees. So the negative part is simply to do with the direction that you go from the x-axis. Now there are 2 ways to deal with negative angles. I'm going to show you both of them, and in all the examples I do, I'm going to do both. And then you must kind of pick what works for you. To be honest, I pick either way. It just depends on what question kind of lends itself to, what technique to use. So I'll show you as we go along. So first of all, let's look at the sign of negative theta. So if I erase my drawing so far, where would negative theta be? Well, if theta was the angle that I have drawn in the first quadrant, negative theta would simply mean that I went theta degrees just the other way. So that would be negative theta. I've gone clockwise by theta. Now the idea of this whole topic is the following. And I've written it in there as a note. And the idea is you can add or subtract 360 degrees as many times as you want to. So if it helps to add 360 degrees, then add 360 degrees. If it helps to subtract 360 degrees, then subtract 360 degrees. The reason being is if you're facing a certain direction and you rotate 360 degrees. So for example, if I draw a line that way and I rotate 360 degrees all the way around, you come back to exactly the same place because there's 360 degrees in a circle. So that's why you are allowed to add 360 degrees as many times as you want, and you will land up with a different number, but it's effectively the same angle. So if we have a look at sine of negative theta, what we can do is we can add 360. So from here to here, I'm going to add 360 degrees. Now if we do that, we will have 360 degrees and then minus theta. Now what I can do is I can do reduction, and I can say, oh gosh, 360 degrees minus theta gives me the 4th quadrant, which is exactly where it is, and in the 4th quadrant sine is negative. So this is negative and reduces to sine of theta. So 2 things to gain from this. Sine of negative theta is always, sine of negative theta is always equal to negative sine theta. It's not that you've factorized out that negative or anything. It's simply because of the step I've showed you. The fact that you can add 360 and then basically do reduction. So I like to remember this concept, the fact that sine of a negative angle is the same as a negative sine angle. It means that I can cut corners. So if that's true for sine, what about cos? Well, let's do exactly the same thing. Let's add 360 degrees because you remember you're allowed to do that whenever you want to. So if I make this cos of 360 degrees minus theta, that's exactly the same thing as cos of negative theta. All I've done is I've gone 360 degrees round and landed up at the same place. Now 360 degrees minus theta, as we can see in the picture, is quadrant 4. And cos is positive in quadrant 4. So this reduces down to just cos theta. So again, something that I just remember, but it comes from the fact that I do the plus 360 and the whole reduction. But if I want to remember this and kind of skip steps, I remember that cos of a negative angle is the same as cos of that angle. So basically the negative sign means nothing when it comes to cos. Let's look at tan. If we do exactly the same logic and we add 360 degrees, so it is exactly the same angle, just 360 degrees later, so it's now 360 degrees minus theta. Now again, this is in quadrant 4, as we saw from the picture, and in quadrant 4, tan is negative. So this reduces to negative tan theta. So again, something that I just remember, tan of a negative angle always reduces down to negative tan angle. So I'm going to write a summary below here of those two things. So basically there's our summary of things that we have just learnt simply because we added 360 and then did reduction. Now if you don't remember that, that's absolutely fine, because you can always go the long way, which is to add 360 degrees. So let's do some examples where we use this concept. So this question says, determine without the use of a calculator, and the first one is sine of negative 45. Now I'm going to show you two different ways of doing this. So if I divide my page in half, the first way is just to say, well, sine of negative 45 equals negative sine 45 degrees. Now what am I using there? There I'm using the concept that sine of a negative angle is the same as negative sine angle. So that's just what we noticed from the previous page. So there, if I remember that trick, I can go straight to the answer of negative sine 45. Now sine 45 we should know is root 2 over 2, but we could use our calculator. Okay, now what happens if we forgot that trick? So, or whenever there's a negative angle, don't forget that you can add 360 degrees as many times as you want. So if you had sine of negative 45 degrees and you completely forgot what that means, not a problem, because I can just say that's great, I'm just going to add 360. And if I add 360 degrees, that's the same as sine 315 degrees. Now sine of 315 degrees is not a special angle, but don't worry, I can do reduction. So this is the same as sine, and I'm going to rewrite 315 degrees as 360 minus 45. Now let's just pause here. Is that not exactly the same as that line there? So in future, instead of actually doing it that way, why don't I write my 360 degrees first, minus 45, and then go straight to reduction? Then I can skip out the step of going down to sine 315 and then going back to my reduction. So actually in future, I'm going to write my 360 degrees first, because then I can say, oh gosh, 360 degrees minus 45 is quadrant 4. So this is negative, and it's sine of 45. And now I can finally say that that's negative root 2 over 2. Okay, so we've learnt a lot of things there. We've learnt that I should probably put my 360 degrees first, because then I can go straight to reduction. Okay, let's try another one. Okay, again, I'm going to divide my page in half, because there's two ways to do it. So the first way to do it, we'll say, oh gosh, we're doing cos, and I remember that cos of a negative angle is exactly the same thing as cos of that angle. The negative plays absolutely no role at all. So if I remember that, I will go straight to the fact that this is cos 135 degrees. Now I still have to do this without a calculator, so I need to set up my reduction. So I need to rewrite 135. So I'm going to rewrite it as 180 minus 45. All I've done there is rewritten 135. So that 180 minus 45 equals 135. Now I can do reduction. And I can say that cos of 180 minus 45, that's quadrant 2, so cos is negative. So this is negative cos 45, and this equals negative root 2 over 2. Now the other way to do it is, don't forget that you can add 360 degrees as many times as you want. So you could take cos of negative 135 degrees, and you can just add 360. So then you'd say 360 minus 135 degrees. Now this is when it starts to get a little bit tricky, because there's now two ways now to progress. You can go straight to reduction. The only thing is this is quite tricky to explain. If I say 360 degrees minus an angle, the important thing is to just think of that as 360 minus, so we're going into quadrant 4. So because we're going into quadrant 4, this is positive cos 135 degrees. And so I get straight back to that place there. Now, the only reason that this makes this tricky is that if you do 360 minus 135, you would actually go into quadrant 3. And so now people are very tempted to put a negative sign there because they're like, oh, but I'm in quadrant 3. Now, the only problem is that you mustn't put that negative sign there, simply because cos 135 is going to land up being negative automatically. That negative sign will come out in the wash. If I put this negative sign there to start with, it's going to counteract the negative sign that's still going to come, and it'll land up positive, which is wrong. So the most important thing is, don't overthink this 360 minus 135. Is that quadrant 3 or is that quadrant 4? Don't even draw a picture. The moment you see 360 degrees minus an angle, any angle, you automatically, your brain needs to go quadrant 4. Don't even overthink it that you're minusing 135, so technically you go into quadrant 3. Don't even think about that. The reason being, cos of 135 is going to land up negative anyway. And so the fact that that needs to be negative will come out later when you do the reduction. And so this is one of the reasons why sometimes adding the 360 degrees gets us into a little bit of a tight spot. So I'm just going to say this again. If you go this route, always just have in your head 360 degrees minus any angle, minus 10 million degrees. Always just think of it as quadrant 4 and base your sign on that. Because now I would change this to cos, and I would do 180 degrees minus 45. Now that's quadrant 2. So now it's negative cos 45, which is negative root 2 over 2. So the fact that this needed to be negative automatically comes out when you do your reduction. Now I said that there was a third way to do this. There is actually a third way, because from this line here, you could have actually simplified that. So you could have gone and said, well, cos 360 minus 135, that equals 225 degrees. And then what you could have gone and said, well, that is 180 plus 45. So that is quadrant 3, which is negative cos 45, and you'd land up at that step. So there's lots of ways to do this, and I think the most important thing is for you to figure out which way works for you. Personally, I prefer to use this first way of just dropping the negative for cos. But, as we'll see from the very next question, sometimes it makes sense to add 360. So if I look at this next one, again, if I'm going with my two different ways of doing it, the first way of doing it is remembering the fact that tan of a negative angle is the same as negative tan of that angle. That's what we learnt in the beginning of today's video. So some people will look at this and say, okay, so this is negative tan of 330 degrees. Now we need to do reduction. So I'm going to rewrite 330 as 360 minus 30. Now that is quadrant 4. And in quadrant 4 tan's negative, so thus is negative tan 30 degrees. So this lands up actually being with positive tan 30. And tan of 30 degrees, if you use your calculator, tan of 30 degrees is root 3 over 3. If you don't use your calculator, you could also get 1 over root 3. It's exactly the same thing, so it doesn't matter. Okay, so that's the way to do it, where you kind of use the so-called shortcut. However, here, if we added 360, which we're always allowed to do, what does tan of negative 330 become? Well, negative 330 plus 360, if I simplify that, well, 360 minus 330 is just tan of 30. So I go straight to tan of 30, which is root 3 over 3. So in this case, adding 360 and simplifying actually got me there fairly fast. So this is why I say I honestly just look at the question and decide based on the question what method makes sense. Okay, so let's have a look at some more. Sine of negative 180. So two different ways to do it. You could have said that this is negative sine 180 because of the shortcut. Now sine 180 is considered a special angle. Once we've done, any of the axes are considered special angles, and once we've done graphs, you are welcome to just use your calculator for axes. So if you pick up your calculator and go sine 180, you get 0. So this is negative 0, which is 0. Okay, or if you add 360, if I add 360 to negative 180, I'll get to 180. So negative 180 would be equal to sine of 180, just by adding 360 degrees. And sine of 180 is 0. Don't forget that any axis, you're allowed to use your calculator. Right, now that we've practiced some negative angles, let's go to some big angles. Any angle bigger than 360 is very easily dealt with. Where is 690 degrees? Well, I would have gone all the way around once, which is 360, and I clearly still have to go more. I have to go around a second time, all the way around to somewhere there. Okay, how do I know how far I've gone round? Well, don't forget you are allowed to add and subtract 360 as many times as you want. So I wouldn't actually write this down, I would just do it on my calculator, but I can take 690 and minus 360. So I get sine, and 690 minus 360 is 330 degrees. So actually, all this means is I went all the way around once, and then I kept on going for 330 degrees. So now I can do reduction on that. I'm going to rewrite 330 as 360 minus 30. 360 minus 30, that's in quadrant 4, so sine is negative. So it's negative sine of 30 degrees, which is negative a half. So angles bigger than 360 are very easily dealt with. So on to the next. Tan of 945, I'm going to minus 360. And if I take 945 and I minus 360, I still get an angle bigger than 360 because it's 585. So you just keep going. And I subtract 360 again. And once I've subtracted 360, again, I get down to an angle smaller than 360 degrees. Remember, you want to reduce it to an angle in the first revolution. Now this is fairly easy to do reduction because I'm going to rewrite 225 as 180 plus 45. That's quadrant 3, so tan is positive. So this reduces to tan 45, which is 1. And to our last example in this one, cos of 495, so I subtracted 360, and so this went all the way down to 135, and now I'm back to a fairly easy reduction. So it's 180 degrees minus 45 is how I rewrite 135. Now that's quadrant 2, so cos is negative, so it's negative cos of 45, and cos of 45 is root 2 over 2. Okay, so now we've done our basic first example of how to deal with negatives in two different ways and angles bigger than 360. Now we need to look at some little bit more interesting things. So in question 2 says simplify, and you'll notice that this is almost like it's the wrong way around. I'm used to having the axis first. So I'm used to 180 degrees plus or minus theta. I'm not used to theta minus 180 degrees. So don't forget that you can always add 360. So if I have sine of theta minus 180 and I don't like that, I'm just going to add 360 degrees. So this actually becomes sine of theta, and minus 180 plus 360 is plus 180 degrees. And so if I rewrite that in the different order, it's back to something I'm used to. I'm used to having the axis first. So I've just written myself a little note on the side there, which is exactly explaining what I was doing. So I added 360 because I didn't like this minus 180. And then I just changed the order to make it more recognizable. Now I can do reduction because sine is negative in quadrant 3. So this is negative sine theta. Right, on to the next one. This is even better because if I take theta minus 360 degrees and I go and add 360 degrees because I'm allowed to do that, the 360 degrees cancels. And so I actually get cos theta. So that's really quite simple. Our next one, This is also quite a nice easy one. Remember, you are allowed to subtract 360 degrees as many times as you want. So if you had this, you could just subtract 360 degrees, which means it would just simplify to tan theta. Or you could think about what 360 degrees plus theta meant. 360 degrees plus theta means around 360 and then through theta again. So you could just do reduction. You could just say, gosh, this will be in quadrant 1, so tan is positive, and so it's positive tan theta. Right, so let's just do two last examples of where it's an exam type question. So an exam type question is where you would have this mixed in with lots of other things. So let's have a look at this. Let's go through little bit by little bit. So personally, if I see sine of negative theta, I use the shortcut. And I say that sine of negative theta is simply the same as negative sine theta. You could add 360, so you could go through the whole process of saying that it's sine, and then you add in 360, and then you have the minus theta, and then you say, oh, this is quadrant 4, so that's why it's negative sine theta. But that's what we did in the whole explanation, so personally, I just use the shortcut. Okay, now if we go to the next one, this says cos squared of theta minus 180. Now, that's not the right order for me. So this is cos squared, and I don't like that, so I'm going to add 360 degrees there. So I'm going to say minus 180 plus 360 is positive 180 degrees, and then I'll write the plus theta. So I've done all that we did in the previous examples in one step. So just to explain there again, I did minus 180 plus 360, which gave me my 180, and then this plus theta, I just put it second because I know that that's the order I want. Okay, now if I look at the bottom, cos of 360 minus theta, that's just normal reduction. That'll go into quadrant 4, and cos is positive in quadrant 4, so that's positive cos theta. And the last one, sine of 180 plus theta, that's quadrant 3, so that's negative sine theta, because sine is negative in quadrant 3. So I haven't quite finished dealing with my cos squared, but I can immediately notice that this negative sine theta and this negative sine theta is going to cancel. So if I now deal again with this cos squared, 180 plus theta, this is in quadrant 3, and cos is negative. So this will be negative cos theta, but I am going to land up squaring it. And this is still divided by cos theta. So negative squared would basically just be cos squared theta divided by cos theta. And so basically I have cos squared at the top and cos at the bottom. So one of them will cancel, and I'll simply simplify down to cos theta. So that's generally a 4, 5, 6 mark question, and really quite nice because it involved a negative angle and the idea of adding 360. Okay, let's look at our last example. First things first, cos of a negative angle. Again, if this was me, I would just use the cheat, and I know that cos of a negative angle is exactly the same thing as cos of an angle, because I'd be talking about quadrant 4. Then I have tan of 180 plus theta. Well, 180 plus theta is in quadrant 3, and tan is positive, so that's tan of theta. Tan of theta minus 360, I would just add 360. And if I added 360, this would just simplify right down to tan theta. Okay, then 180 plus theta is in quadrant 3, so sine is negative, so that simplifies down to negative sine theta. And finally, tan of a negative angle is exactly the same as negative tan of an angle. I'm using the shortcut there as opposed to the fact that I could add 360 and then do reduction. I'm just cheating a little bit. Okay, now if we look at what cancels, first of all, I've got a negative at the bottom times a negative, and so immediately I know that all my signs will cancel. And I've got a tan and a tan. So this is going to simplify down to cos theta times tan theta all over sine theta. Okay, now I've been hinting at something a lot, and it's something that we're only going to do after we finish reduction, and that's identities. But it's nice to see identities the whole way through, because then when we get to them, they really have already kind of sunk in. So at this stage, if you left the answer like that, I'd say absolutely fine. In the long run, however, we are going to prove something we've seen quite a couple of times now, and that's the fact that tan theta is sine theta over cos theta. So whenever I see a tan and I'm trying to simplify, I can go and rewrite it. So this is cos theta, but now I'm going to rewrite tan theta as sine theta over cos theta. And this is all over sine theta. Now you'll notice what happens is that this cos cancels with that cos, so I actually end up with sine theta over sine theta, and that simplifies then down to 1. Okay, so what's the summary of this video? The summary of this video is the fact that you may add 360 or minus 360 as many times as you want. So when it's helpful to do that, go wild. And the other thing that, just to summarize this video, is what I've put in a little bubble here, and those are the 3 kind of negative angle rules that you're welcome to remember. You don't have to remember them, because I have shown you that you can always just add 360 and you'll get to the same answer. Hopefully we've also done quite a lot of practicing of reduction here, and we're going to get really, really good at it.